Hi guys! Okay, we're going to start 2.5, and it is reasoning in geometry and algebra. And 2.5 is when we get to start the wonderful world of proofs. Yay, proofs! Alright, so in order to do so, we're going to need to go over a lot of properties so we can actually do one of these proofs. Don't worry, we're going to do some in class, but I need you to memorize these properties. So the first one we start with is the reflexive property. I recommend making a Quizlet or flashcards if you are not a good memorizer. So it says that for every number a, semicolon, a equals a. For example, 1 equals 1, or negative 10 equals negative 10. To help you remember reflexive property, remember when you look at your reflection in the mirror, you see yourself. That is reflexive property. We're going to move down here to symmetric property. All right, for all numbers a and b, if a equals b, then b equals a. Symmetric, they just flip around. So here's an example. If x equals 5, then 5 equals x. That's the symmetric property. You need to know these. I can't stress that enough. All right, and then we're going to talk about addition and subtraction properties of equality. All right, so for all numbers a, b, and c, if a equals b, then a plus c equals b plus c. All right, that's the addition portion. The subtraction portion says, and if a minus c, it will equal b minus c as well. All right, so let's say we have 2x minus 10 equals 20. All right, if we went ahead and added to it, added 10 and added 10, that would be the addition property, and we would end up with 2x equals 30. That's the addition or subtraction property of equality, just like algebra. Do whatever it's telling you. Do the same things to both sides of the equation. All right, so here is the multiplication and division property. For all numbers a, b, and c, if a equals b, then a times c equals b times c. And if c does not equal 0, then when you take a and divide it by c, it will be equal to taking b and dividing it by c. So example, if I divide by 2 and divide by 2 to solve for x, then x equals 2. Basically, with addition, subtraction, multiplication, and division properties of equality, what you do to one side, you have to do to the other. All right, then we're going to talk about the substitution property. For all numbers a and b, if a equals b, then they may be replaced by b in any equation or expression. So, if we have m and it equals j, and m plus j equals h, then I can, instead of using m, I'm going to take and put j plus j, and that's going to equal h now. So remember, m equaled j, they're the same. And I originally have m plus j equals h. But instead of using m, I'm just going to substitute j in since they're the same thing. And I will have j plus j equals h. Next, I'm going to have the transitive property. And what it states, this is very similar to the law of syllogism, basically the same thing. For all numbers a, b, and c, if a equals b and b equals c, then a equals c. So like the law of syllogism, we have this common term, right? And we eliminate the common term. So if a equals f and f equals g, the two common pieces, the f's, we're going to get rid of, and we're going to say that a equals g. That is the transitive property. You will be using it a lot in your proofs. Okay, and then we talk about the distributive property. All of you should have at least heard the word distribute at this point in your math careers. For all numbers, A, B, and C, if you have A on the outside, in parentheses, B plus C on the inside, that A gets distributed to each of these letters. A times B, A times C. It equals AB plus BC. So with actual numbers, it might look like this: 3 parentheses, 10 plus 2, close parentheses. We would distribute that 3 and distribute that 3 with 3 times 10 and plus 3 times 2. Okay, so those are the properties that you're going to need to know. We're going to right now go through a pretty straightforward proof. And what is going to happen is, in most of the cases, you are going to be given the statements, and you'll have to fill in the reasons. Every now and again, you might have to fill in a statement, but for the most part, it's the reasons. So, this is an algebraic proof, meaning it's just walking you through the algebra steps that you're used to and comfortable solving. All right, they give you this problem, 3 parentheses x plus 4 equals 9x minus 18. And they want you to prove that x equals 5. So what we're going to do is we're going to take the first equation that they give us, and we're going to start solving it. And in order to do that, we're going to need to distribute that 3, right? So we multiply 3 by the x plus the 4. And I just said the word distribute. So my reason would be the distributive property. How did I get from our original statement right here, the given, right? This was our given statement, so we write given next to it, to this statement down here, the distributing. 3x plus 12 equals 9x minus 18. I multiplied 3 by x plus 4. I used the distributive property. Now, how did I get from this step where I distributed down to this step? Well, what I did is I went ahead and I subtracted 3x from both sides. Subtracted. So I went minus 3x, and I got 12 equals 6x minus 18. And that would be the subtraction property of equality. I went ahead and subtracted 3x from both sides. Well, what happened here? How did I get from 12 equals 6x minus 18 to 30 equals 6x? I added 18 to both sides. I added. So plus 18 plus 18, the addition property of equality. Okay, so now I'm at 30 equals 6x, and I want to know how I got down to 5 equals x. Well, I divided 6 by both sides. Divide by 6, divide by 6. Because I divided, it's the division property of equality. And then I have 5 equals x. Well, I end up with x equals 5. I just flipped it around, right? And when we flip it around like that, we call that the symmetric property. That is your first proof, and you will be getting to do more of these fun fellas in your near future. See you tomorrow. Bye.